Okay, so we are going to do 6.2 on parallelograms. Just a quick reminder, definition of a quadrilateral, that's just a four-sided polygon. All right, so basically the rest of chapter 6 is all going to be focusing on special types of quadrilaterals. Okay, in this section we are going to take a look at parallelograms. So the definition of a parallelogram, if we just look at the word itself, right, the first part of the word, parallel, so it's a quadrilateral with both pairs of opposite sides being parallel to each other. So here we have a picture, AD and BC are parallel, AB and DC are parallel. And then you'll see there's a little symbol in front, so just like for a triangle, okay, if we draw kind of a parallelogram, that's kind of our abbreviation. Now, we have a number of different theorems on parallelograms, and you'll notice here they all have like this little symbol in front, right? The little parallelogram symbol, and then an arrow. This just means, this is like an if-then statement. So basically we're saying if it is a parallelogram, then what is true? Okay, or you can think about it, a parallelogram, the arrow can be read as implies. Okay, so the first one is, again, all we know based on the definition is that opposite sides are parallel. But if we know that's true, all these other theorems will follow. So the first one is parallelogram implies opposite sides are congruent. So that means these two sides are congruent, these two sides are congruent. Okay. Next we have a parallelogram implies opposite angles are congruent. So opposite angles would be here and here. Those have to be congruent. And then these two would also have to be congruent to each other. Okay, third one, parallelogram implies consecutive angles are supplementary. That one's pretty obvious just because, remember, if these are parallel lines, right, and if this is 60 degrees, this has to be 120 because they are consecutive interior angles. And then similarly, right, the other lines have to be parallel, so this would have to be 60, this would have to be 120. So if you kind of look at all of the consecutive angles, will have to be supplementary, have to add up to 180. Okay, this is a special one. Basically, if you have one right angle in a parallelogram, so if that's one right angle and that's all that we know, and we know this is a parallelogram, automatically, based on our previous two theorems, right, we would know, okay, opposite would have to be a right angle, and then consecutive angles would also have to be supplementary, so those have to be right angles. So basically, if you have one, you automatically have all four. This one, see another big one, if you have a parallelogram, the diagonals bisect each other. So that means this diagonal and this diagonal, they're cut in half. These diagonals are not congruent, but what ends up happening is they get split into two smaller congruent parts. So each diagonal is cut in half. And then lastly, if I were to draw a diagonal, that's going to separate. So if I were to draw this, basically these two triangles, so I'll say, let's just name this parallelogram ABCD, we could easily prove that triangle ABC has to be congruent to triangle CDA. We're not doing any of those proofs, but just, think back to how we could prove that. We've got parallel lines, so you'd have alternate interior angles congruent, right? And we can use some of the previous theorems as well. Okay, complete each statement about parallelogram QRST, and we want to justify our answer. So when we justify, we're going to use anything on this first page. So you can use any of the theorems and possibly even the definition. So this is a part where if you want to pause the screencast and see if you can answer these on your own and then press play to see if you got them right. Okay, SV congruent to, so SV is part of the diagonal, so SV has to be congruent to VQ. Now my reason is a parallelogram implies diagonals bisect each other. Okay, angle SRQ. So SRQ is this angle. That's going to have to be congruent to angle STQ or QTS because those are opposite angles. So my reason is parallelogram implies, and we could do some abbreviation, opposite angles congruent. All right, QT. So that's a side. That has to be congruent to RS because those are opposite sides. So parallelogram implies opposite sides congruent. Okay, next we have triangle SRQ. Okay, that has to be congruent to this other triangle here. So that's going to be triangle QTS. And the reason, okay, that was the one, the very last one, diagonal separates parallelogram. This one's kind of hard to abbreviate here. Separate parallelogram into two congruent triangles. And lastly, we have TSR has to be supplementary. We actually have two options. So when we're talking about supplementary angles, we're thinking of the consecutive angles. So you could have actually QRS or angle STQ. And the reason is parallelogram implies consecutive angles are supplementary. Okay, example 2. Use parallelogram JKLM to find each measure or value. Okay, so we want to find the measure of angle MJK. So that's that angle. And if we look directly across, those two angles are 30 and 70. So therefore, MJK also has to be 30 and 70 combined to make that 100 degrees. Measure of angle JML. So that's here. Well, if this is 100 and this is 100, then those angles have to be supplementary. So that's going to give us 80. Okay, next we have, so this was 80, JKL. So JKL is opposite that angle we just found. So that has to be 80. And the measure of angle KJL. KJL is this angle here. And that has to be congruent to 30 because those are alternate interior angles. Okay, and lastly, we have to solve for a and b. Well, 3a has to be equal to 21. Oops. So a is 7. And then we have 2b plus 3. That has to be equal to its opposite side, which is 45. So we get 21. Okay, so that is it for this screencast. Go back to your paired deck and finish those slides. And then you can find the worksheet for homework on MyJag.